We're going to go ahead and get started here, and I'll go ahead and kick us off. All right, thank you everyone for joining. Thank you. This is our February webinar for the student user group for the Mainframe Open Education hosted by the Linux Foundation. If we want to go to the next slide, what the Mainframe Open Education is we are trying to help people learn and understand more about the mainframe. So helping new mainframe talent, also helping people to be able to build their skills and also roadmaps, etc. If you're curious about mainframe and want to learn more, you're welcome to go to the websites here. And if you not only learn more about the mainframe, but also connect with people who are working in that space and be able to not only learn the content, but also learn from each other as well. And there's lots of wonderful information and resources there that can help get you started. We'll go to the next slide. And just a little bit more about the Mainframe Open Education Program. Also, again, hosted by the Linux Foundation. You can go ahead and scan that QR code and learn more about what's called Get Involved. Kelsey, did you have anything you wanted to add about Get Involved?
Yeah, so this campaign is something we started because we found that a lot of people wanted to be involved but weren't necessarily sure where to start. So we created a very simple path that you can all do starting today. It includes actually joining the Mainframe Open Education Gitbook. It involves sharing your story on our Mainframe Journeys page, which everyone can do regardless of how much experience or, technical expertise you have. We welcome everyone to share your story in terms of how you came to the world of mainframe. There is a template here, so it's easy for you to just copy, duplicate that page, and add your story to our repository there. We then welcome you all to kind of explore the Gitbook and start contributing to it. It can be something big, it could be something small, it can be as simple as, hey, spelling error, or it can be suggestions for new topics. And then we welcome everyone to continue to attend events, including events like today's. And then once you have completed all of those steps, you can actually earn your MOE member badge. So this is something that you can earn there. And we hope that in future months, we'll have different topics. So this month, the Get Involved campaign started with the Share Your Story, but we're hoping that every month we have additional topics where you can actually contribute to other sections of the Git book and continue to be involved with us there. So as Phil, as you mentioned, there is a QR code that you can scan, and then I'll throw into the chat as well the link for that page within the Git book that has a little bit more in terms of this program and kind of how you can get started there. So that's what I have for today.
Perfect. Thank you so much. All right. So we're going to go ahead and introduce our speakers here. So I'm actually really excited about the lineup that we have here. We have Dave Helsley from IBM, from Broadcom, and sorry about that, Dave, from Broadcom, and is just been a, a wealth of knowledge. He has done everything that I can think of as far as when it comes to IT tools and technology and software. And I'll let him introduce himself a little bit when we get to his portion of the webinar here. And we also have Kyle Becker, who is a very strong and uh, profile here with the learning about AI. And I was lucky enough to go to one of his sessions at the AI meetup and was just blown away by what he had to share there. And I'm so thankful that he's able to be here to share a little bit of that with us today here. And so I'm going to go ahead and kick things off to Kyle and let you introduce a little bit more about yourself here and share a little bit of what you have to say with us today. Thank you.
Sure, absolutely. Thanks, Phil. Thanks for the introduction. And Phil, remind me, how much time should I eat up for this webinar?
Yeah,
I don't want to take too much time, monopolize.
yeah, about 20 to 30 minutes
Okay.
if you can keep it around there. Yeah,
Yeah,
that'd be
sure.
great.
So I'll introduce myself. I got a kind of my slide deck here that we can show you some conceptual things and then dive into a very brief demo on, what we can do. But I'm Kyle Becker. Grew up in West Virginia. I live in Dallas, Texas now. My background is largely the military. For a very long time, I was in the Marine Corps, about 16 years, 12 on active duty, 4 in the reserves. And when I was in the Marines, it was my MOS, my job was reconnaissance. So, we had to collect data about, the environment, the bad guys, roads and streams, um, and synthesize that all into these reports that were useful, that achieved what's called CCIRs, Commander's Critical Intelligence Requirements. And if you were to think about, what that could mean in the more the business corporate sector, that's like your KPIs maybe, or your maybe not KPIs, but just certain objectives or important insights, that are important to commanders so they can make more informed decisions about troop movement. So I am a believer that, information and the right type of information is very powerful. If not, you're just working with your gut, and some people's intuition is better than others. But when we have all these tools in which we can collect data and surface insights from them through statistical methods, why not do that? Why not put that system in place? So that's what I do now. I'm a data and AI engineer. I'm also an AI strategic advisor as well. And the company I work for is called Lantern Studios. We're a North American based company. It's a consulting advisory firm, and we have offices in Dallas, Portland, Oregon. We have one up in Canada, in Colorado as well. But yeah, I mean, largely what we do is we help our clients with data and AI solutions, right? So we like to start with your data estate first because everybody knows garbage in, garbage out, but in the age of AI, that takes on a really serious sort of exponential tone in which, because, AI learns a lot of times on the same data it generates, right? So if that data is bad, it creates this like toxic sludge. Everyone has seen, AI weirdness, AI slop. If that information gets recycled into the AI's learning environment, then that's not good. It makes the problem much more worse. So at Lantern Studios, we start with your data estate. We're a Microsoft partnership organization. So we work with Microsoft tools like Azure and Fabric. Um, and so if you've heard of, like Azure AI Foundry, Azure Data Factory, uh, Azure Machine Learning, those are the tools we work with. And now Microsoft Copilot is a big one as well. So yeah, that's a bit about me and my background. Now I want to share some slides here. So I'm going to go ahead and share my screen. Hope I don't mess anything up here, especially when I go full screen. All right. Phil, can you see that? Is that the slide deck? Oh, no, we're not sharing yet. Here we go.
Yeah, there it goes.
All right. I'm going to go full screen here. All right. So I call this deck Riding the Curve. So this is about AI. Essentially, the issue a lot of organizations are facing is that it's implemented somewhat piecemeal. There's not a unifying strategy. And there's a lot of reasons for that. Is one, it is a big investment. Two, a lot of this stuff is unproven. There's a lot of tools that fall at various spots on the Gartner hype cycle. Is it all hype, or is it in the trough of disillusionment, or are we at the, what is it called, the plateau of what is it called? The plateau of reasonableness, like where these tools are proven out, right? So, um, because this technology is so nascent, a lot of organizations, are resisting the urge to chase after every shiny ball, which is good, but how do you distinguish that and something that the company really should embrace, right? Or they risk becoming obsolete, like Kodak not adapting to DSLR, right? Or Blockbuster not adapting to um, streaming services, right? There's a whole historical graveyard of companies that didn't adapt, but equally so, there's also companies that have gone bankrupt chasing after, hype and buzz. So it's really important to be able to distinguish between the two, right? So that's kind of what this slide deck is about. The upside is exponential and the downside is existential, right? If you don't adapt to this technology, right, it could be an existential crisis for your company, right? And changes happen ever since the invention of the wheel or the invention of fire, right, or the invention of agriculture. It's displaced people's existing jobs, and they've had to find other things to do, right? That epical that chasm, right, needs to be crossed, right? And but the question, and it's going to happen, right? And corporations and people need to adapt. The question is, how do we do this while being as least disruptive and as ethical as possible to our workforce, right? How do we retrain? How do we upskill? And how do we augment AI in such a way to where people can keep their jobs and continue to grow with the company. Right. So yeah, AI is accelerator faster than traditional enterprises. Organizations that move early capture compounded productivity, revenue, innovation advantages. This is about the law of accelerating returns, something Ray Kurzweil in his book, The Singularity is Near, coined, I believe. And we have a slide on this later, but it's all about with technology, things, returns can compound and have a positive reinforcing feedback loop. But if you don't embrace this technology, it kind of has a downward, sort of a inverse downward cycle, right? Which again, I'll wait till we get to that slide to talk a little bit more about the law of accelerating returns. All right, so the shift is already underway. AI is reshaping how work gets done across every function. Leaders need to adopt new tools, redesign operating models. Um, yeah, and so what does that look like? So with your company's traditional organizational chart, you see there on the left, this is just an abbreviated org chart where you have three different departments staffed in total with 10 people. Now, I don't like the idea, and we at Lantern, we wouldn't advocate the idea of, redundancy, quickly replacing people and with AI, right? We believe it doesn't make business sense, financial sense, or sort of more. It's not good moral judgment either. And so, what we advocate for is augmenting people with AI and reskilling them and redesigning your job functions and your operating models to where both humans and AI are integrated. Now, why does it not make sense to lay off, employees and cut that cost and just if you can replace them with the AI, why doesn't that make financial sense? It's because you're sacrificing long-term gain for short-term benefit, right? It's kind of a classic problem, right? You're reducing costs, sure, in the near term, but your company's not going to be able to learn, grow, and adapt if you don't have humans there learning those skills, especially entry-level positions. And this is really important because if you take out the bottom rung of the ladder, right, your associates, your analysts, your interns, um, you don't have a pathway for people to learn foundational skills in your company, right? And grow into these positions that are more managerial, supervisory, where they really need to have a control over AI, right? Who's going to control your AI if you don't have a pathway for people to climb the ladder in your company and achieve those supervisory positions, right? So don't do that. Even if you can replace an intern with AI, don't do it. Instead, think of ways where you can integrate AI with that intern to make him or her more efficient at their job. So before I move on, what's important about this slide is you'll see there on the right, we've added a new department. Our organization has grown, exponentially. It's grown a lot with autonomous AI, with helper AI, these augmented guys. But our workforce has remained the same. So our company continues to grow, but our workforce either stays the same or grows linearly. But the total workforce is growing at an exponential curve. So that's the idea there. We're not letting anybody go. Okay, so what Lantern Studio does, I'll go through this slide pretty quickly, but we want to understand your company first, um, know your strategic objectives, understand your pain points, understand your goals, and we help develop a roadmap. Then, as I mentioned earlier, we usually push to get your data estate in order and clean first. That way, when we put an AI solution on top of it, it has good data. And the tools we use for those AI solutions are things like AI Foundry, which is super cool. It's highly personalizable and customizable. You can take in and out different large language models, whether you want to use Claude or OpenAI or Meta. It's very modular, right? You can put guardrails in place. You can integrate, database. RAG is very intuitive. In Azure AI Foundry, it's retrieval augmented generation, right? It's where you're incorporating different knowledge that your AI will prioritize. AI Foundry also allows you to fine tune and fine tune in the technical sense. A lot of people use that term fine tune, but the technical definition of that is when you actually alter the weights and biases of your large language model. And if you're not familiar, these neural networks that LLMs are uh, that LLMs are made of neural networks that sort of imitate the human brain with synapses and neurons. They call them weights and biases, and they're normally fixed and proprietary. But there's also a lot of large language models that are open source, and you can use something like LoRA. LoRA. It stands for low rank adaptation, which will actually allow you to change how your AI's mind is wired, right, to be more in tune with your own corporation's standard operating procedures, tone, culture, things of that nature. It's a challenging thing to do. It's not as easy as RAG or prompt engineering, but AI Foundry equips users with the tools to do that fine tuning. So it's super cool. Okay, now, but what I think is even more exciting than that is Microsoft Copilot. Um, because I read this quote, I need to credit this author, but he says that big disruptive changes happen not when impossible things become possible. That's exciting, and like its breakthroughs are amazing. But the real disruptive change happens when those hard things become easy and ubiquitous, right? You can take, for example, I remember I was about 10 years old when Windows 95 came out. And I think my understanding, and this may not be entirely accurate, but my understanding was that was a big watershed moment because personal computers went from something kind of esoteric and something that computer wizards or nerds, like you knew how to program and write in these command line interface languages, like DOS and so forth. You knew how to programmatically, interact with computers. Windows 95 really popularized the graphical user interface, right? So now you're just pointing and clicking and opening things up, right? So we went from CLI to graphical user GUI, right, to GUI. And that made Bill Gates the richest person on earth, right? Because Windows sales just exploded. Everybody was buying personal computers. So um, I believe that Microsoft, in a big way, they're not the only person who gets credited with this, but Microsoft Copilot, in a big way, is taking something that AI that used to be kind of hard to do. Like I remember programming machine learning models, right, where you're making predictions on horse racing or baseball statistics or sales forecasting. It's pretty tough, picking different algorithms, doing what is it called, feature engineering and things of that nature. that it's more of a genesis of AI programming has now become more graphical. Things like Copilot Studio allow you to, without needing to know any code, you can integrate the data you want. You can make connectors to different tools. You can make it follow deterministic workflows, which I'll show you here in this demo, which I better hurry up and get to. Um, and it does take some training, and it does take a bit of skill, but that's why I mentioned earlier, it's this AI shift is just as much as a human problem as it is a human challenge, we'll say, as it is a technical challenge, right? I think the person who should be most involved in AI workforce transformations is your chief people officer, just as much as your chief digital officer, right? It's integrating the human with the technical aspects of these transformations is most important. So, in Copilot Studio, for example, your HR department should be helping writing, job descriptions and career progression roadmaps based on how well you know Copilot, for example, because that means the employee knows how to interact with AI in a way that's achieves real business results on a level that's not all that technical, right? I hope that made sense. But anyways, that's a long-winded way of saying Copilot is intuitive, it's easy to use, and has very high business impact. Um, Now, I remember Phil was saying he really liked this slide right here. And this is another slide I can't take credit for. And I need to give credit for whatever author it was. I've read a gazillion AI books in the past few years. What is this one from? But this is a good way of thinking about the different mindsets towards AI. And this is really useful framework if you run an enterprise, right? And because a lot of people are really apprehensive and scared or overly optimistic about AI's impact, both in the business world and in personal lives and society as well. So depending on what temperament your folks fall into, equips leaders to um, come up with the correct your messaging, maybe not correct messaging, but the ideal messaging to sort of persuade and communicate AI initiatives to your workforce. So we have doomers, gloomers, bloomers, and zoomers. So on the left there, doomers and gloomers, that's kind of your negative perspective. On the right, your bloomers and zoomers are your optimistic perspectives. Um, so long story short, try to be a bloomer. Bloomer are the people who are cautiously optimistic about AI. They understand that there are real benefits. It's important to not get left behind, and we should be learning AI, but we want to do it in a responsible way that minimizes, security breaches, data leakage, right? That minimizes job place disruption. You don't want to fire a bunch of people because AI works, only to hire them back again because it doesn't work as good as you thought it did, right? So yeah, cautiously optimistic are bloomers. Zoomers, we'll just go to Zoomers down at the bottom right. They're people who, a lot of times, Zoomers are misanthropic. You guys know what that means? Like they like technology more than they like people. I think like Larry Page would be a good example of a Zoomer. Uh, yeah, they just want AI to get here as soon as possible because they believe it's inevitable and they want to usher in our AI overlords, and just get it over with. They probably have, utopian ideas, but I would not advocate for being a Zoomer. I don't believe we know everything there is to know about Zoomers. I don't think the futurists are always correct, right? So we need to approach this thing optimistically, but we also shouldn't be doomers. I don't think it's a doomsday event, right? And gloomers, they're the people who just begrudgingly accept it. We need to help gloomers be a little bit more optimistic. So those are 4 quadrants there. And then finally, here's our law of accelerating returns. So this chart on the right, what it shows is exponential versus linear growth of AI. And there's lots of important things to take away from this. I'll touch on a few. One is when you implement AI initiatives, the sponsors, the leadership, everyone needs to be aware that this is an investment in time and money up front, and it's a shift in your operation model. And therefore, there's probably going to be a lag before you start seeing returns. So just be prepared for that. You see that dip at the very bottom, right? The cost of law of accelerating returns. But once, people get trained, you augment your workforce, you have the guardrails in place, you equip people with the tools they need to leverage AI, they understand ththose tools, and becomes fully institutionalized throughout your company. Man, then you're automating stuff, you're returning better answers, you're outpacing your competition, and it just continues to feed back into the solutions to make them even better and better, right? And that's why you start to achieve, in theory, I guess, I don't really think it's theoretical, but compounding returns, accelerating returns. I'll give you one short example. Computer aided design, right? CAD. If you guys are familiar with that, it's when the first CAD software came out, it was really cool, but it was clunky. But what it allowed programmers to do is create better hardware, right? And with better hardware, the computers became more efficient, right? And they crashed less, and it just better hardware made the software work better as well. And as the software got better, so did the hardware, and it created this positive reinforcing loop in which computers are where they are today, partly because of the positive CAD feedback loop, right? So you see that all over the place, the law of accelerating returns, and it often applies in the tech industry and tech tools and things like that. So if you extrapolate the law of accelerating returns or that CAD example to AI, then you can imagine, exponential growth can happen all over your company where AI is applied. AI, generative AI in particular, how it's different than technology like digital photography or streaming services, those examples I brought up earlier, or what else? What are some other examples? The difference between that type of technology and generative AI is generative AI is very broad. It applies very, very broadly, right? Whereas streaming service was a very specific disruptive tool, right? So what does that mean? Like, how should we, what takeaways do we have from that? Well, because it's such a broad tool, we need to apply it broadly, right? In order for it to have sort of maximum impact, right? And this also takes a bit longer. It's a lot longer of an investment in time and money for it to see returns. But you do reach that point to where you can accelerate past your competition once it's broadly implemented in an entire workforce transformation effort. So I think I'm at time already.
Yeah,
For one, can I give just a quick snapshot of the demo of the Copilot, or do I need
sure. Yeah,
to?
yeah,
Okay,
yeah. Yeah, just real
okay,
quick.
just real quick. All right, so this is Copilot Studio, guys. Um, right here are just the agent demos I've created. I created one for claims intake, and you open this guy up, right? And you have all the parameters, all the features of which you can tune your AI agent. Here are the LLM, the brain it uses. You can switch between these different GPT models, but you also have Claude as well, right? So that's the brain. Here's the prompt instructions. All right, here's the knowledge. I gave it a Word document, right? Claims intake process, so it knows how to understand the process. Then you can equip all these different tools, right? Here we can this AI agent can send out emails, but it can also put in Word docs and spreadsheets and databases and things like that as a tool as well. And then this is the last thing I'm going to say because I think this is really important. Topics. Now, hallucinations are a problem, right? These are non-deterministic probabilistic models, LLMs are. They always say something different, even if the input is the same every time. So that's both good and bad. One, it's more natural, it's more like a human, but it can make mistakes. So how do you reconcile probabilistic thinking, all right, so it doesn't make mistakes? Well, you integrate deterministic thinking, which means there's a set path, right? So given a particular topic, it can only answer in certain ways, right? So that's what you have here with topics. So claims intake, right? You can see when someone asks a question about claims, the LLM, your agent can't just make stuff up. It has to go to this next node right here and answer in these ways, right? And it follows the same conversation path down depending on the answer of the user. And then finally, we capture information. We capture information in variables, right? So again, that's deterministic. You can't just make up someone's name or job position or whatever. It captures the information in variables, and then it uses this tool down here at the bottom, email, to send out that claim, right? So we've done a great job of blending a non-deterministic, really smart guy who can make mistakes with a deterministic pathway, right, to reduce or eliminate inaccuracies, right? So that's Copilot Studio. It's a great tool. It's no code. Well, or you can code if you want to, but if you don't, it's no code. So um, it is very much a human-centric AI tool, non-esoteric AI tool that I believe is disruptive, for organizations to adopt and embrace. So. All right. Thanks, Phil. Sorry, Dave, went
Yeah.
over time a little bit, but
No
No,
worries.
thanks for sharing. Yeah.
yeah.
And then,
Okay.
yeah, now we're going to hear from Dave. Go take it away, Dave. Thank you.
All right. So you saw the bio in the very beginning. I've been in the business for about 40 years, 40 plus years. And I started off as a COBOL programmer at a large insurance company. And we had a 10-week training program. And I went through that with a bunch of other folks. And then we were brought upstairs to work with everyone. And I was assigned to the batch leg of the claim payment system. And that's where I learned that at night, if you were on call, you could get that call because your batch job didn't work. And you got this ream full of paper, and you had to go through and figure out why that program failed and get it working because it was a critical time to get everything done in that batch leg before the online started the next day. So that was fun. Then I got into the data center, became a systems programmer, and just kept going. And got down to the assembler layers, and then I started to work my way back up after writing some products. I ended up learning a lot about what IBM is doing to uh, enhance the Z mainframe experience. And so we brought in all the different languages that you all know, the Javas, the Pythons. It's all available on the different operating systems that the Z platform supports. And containers are there, so you can do Docker, development and all that sort of thing. We have some of our products at Broadcom that rely on that infrastructure, Kubernetes in particular. So that's all on that platform. And so what I'm going to do today is take you through a little journey of what the mainframe is, and then end up with showing you the AI capabilities that are built into the mainframe. So with that, let me get my share started. All right. So when I first started working, this what was it, 3090 mainframe is the main box that you see that's shaped like multiple crosses. And then in the lower left, or the left side of the picture in black, is a Z box, a Z17 box. So you can see that the form factor has been changing significantly over the years. And in fact, IBM went from running these water cooled, where the engineering that they had to put into these boxes to keep them cool was incredible, to what they called CMOS, which were air cooled systems, and they were much smaller, but they were slower. So IBM introduced this concept of clustering, which we call sysplex. And so we've had since, at least the late 90s, this clustering capability for high availability. Everything's redundant. And we used to have all the water cooling under these floors, these raised floors, and all the cables are under there and all that. And IBM has gone away from that. the CMOSs were slower, but they started to speed them up, and they got faster and faster. And then they brought in the cooling. There's sort of some type of an enclosed system that keeps them cool these days. So let's continue on this journey. So this is a Z10, which is an old box. They don't even run anymore. IBM doesn't support them. But I happen to have some pictures inside of a data center. And what I noticed was when I first was, in the data center, everything was all around the mainframe. You had the operators out on the floor wearing, coats because it was chilly, and they were grabbing tapes. And I'll show you a picture of a tape machine in a minute. And managing the jobs. They were starting jobs and stopping jobs and doing all this type of stuff. And then eventually, it turned into a command center type of environment where those operators, like Kyle was saying, they didn't lose their jobs, even though they're no longer clustered around the machines out on the data center floor. They went into a command center and they started to write automation on the traffic of the console. A console is something that just keeps getting messages and messages. In Linux, you might think of it as a var log like file that the operating system will write to. We have a similar thing. And these messages could be automated. And so that's what these operators morphed into. And so you see on the right-hand side, the insides of that Z10 box, it's just a bunch of gobbledygook wires and stuff and different types of PCIe cards. And when I show you the slide of the Z17, it'll make a little more sense. And this is it. So this is a fully configured Z17. They fit in 19-inch racks. So now these, where I said the whole floor was dedicated to the mainframe, when I went back into a data center, I don't know, maybe 10, 15, 20 years ago, the mainframes were stuck in the corner. And it was all the floor space was eaten up by these x86 servers. I was blown away. And they were all in 19-inch 19-inch racks. And the mainframe was just shut off in its own little space. And it just felt sad to me that the mainframe lost all that. But actually, it's because of the form factor just got to be so compressed. These are such powerful machines. And there's, these CPC drawers. You can see 4 of them with the red attached to them. And then we've got these IO drawers, which are on there as well. And they give you, the capability to just scale out in incredible ways that just means that these boxes that are now down to a 4 rack enclosure are able to be so much more powerful than the 86s that they can replace. So here's some key bullets on what a Z17 can do. We have these things that we call LPARs, logical partitions. We can have up to 85 individual LPARs on one machine. And then you would probably, in the case of clustering, want to have at least 2 machines, because if you lost one, and you would want to cluster these LPARs together, these partitions, in up to 32-way systems, so that you can have high availability. You can route around problems on your system. There's all sorts of components that do this for you. You can see there's a ton of engines that you can have, 208. Now, the different engine types, I'm not going to get into today. In fact, a lot of this talk, I have more material that we would be able to share, especially on the AI side. So if you feel like it's just whetting your appetite, there's a lot more we can do for you down the road. You can see that these machines support an incredible amount of what we call main memory, 40 terabytes. That's incredible. And then we have, as I showed you on the prior slide, these IO drawers. It supports up to 12 IO drawers, and each of these drawers supports 16 PCIe slots. So that's 192. And what do you put in there? You put in special cards like crypto cards, the Spire, which is the new AI capabilities for large language models. Your network, which we call OSAs or open system adapters, are in the IO drawers. And the FICON is like a fiber connection, but there is a twist on it. It's got a Z architecture, but it is still the same fiber that you would have for like your network or any of your other x86 environments that are talking to their disk. Now there's a slide there, a bullet on how much one individual ZOS LPAR can take 16 terabytes. That's quite a lot. And we have in the mainframe these specialty engines that are channel subsystems. We call them chipids, channel IDs. And these individual engines offload all the work from the main processors. The main processors just start an I/O operation, and these channel subsystems take it from there and move the data from main memory over to the control unit, whether it's DASD or tape or printers, whatever, or even on the OSAs, the network cards. And then when the I/O completes, it will interrupt the processor. But it's already, if you're doing a read operation, it's already moved that data from wherever it got it from to main memory. So the engines are freed up from all that kind of stuff. So let's move on from there. Tape is kind of special to me. I wrote a product that did a lot with virtualizing tape. And in fact, what I have on the left-hand side is the old style cartridges that have autoloaders in them. So the operator would put blank scratch cartridges is what we call them, stack them up in there. And then as someone would, a program would call for a tape mount, and if it were scratch, it would get it from one of these autoloaders. And then when you wrote to it and got done, it would spit it out. Then the operator would have to go grab that and file it away in the racks that held all the tape. On the right-hand side, we moved away from those manual cartridges to automatic tape libraries, which means that the cartridges are inside that big structure, and we have robotics inside that we're running up and down the length of the machine, pulling the cartridge from its place that it knows where it is, and puts it into an open drive. And then when it's done, it will put it back. So that was kind of cool. These days, though, there is no more physical tape on the mainframe. None at all. It's all virtualized. Now on the disk side of the house, you can see on the left-hand side, we have these controllers that have dual power. You've got multiple channels. These are those chipids I was talking about, where you have these high-speed computer that offloads the main processors from doing any work. Just start the I/O and it will, route into the control unit. And then we had these disks underneath. These are what we also call DASD. And you have a track, which is one of those platters on the right, and then the aggregated amount of space up and down, there's like 15, it was known as a cylinder. So you would have a head that would reach inside the cylinder, the disks, and read scan and look for the information that you were requesting. You had special commands, CCWs, channel command words, and you had a special count key data way of doing things. And we can get into those kinds of details if you're interested in it. I'm going to stop there. But we had these things called head crashes, where if the arm reaching in there happened to nick one of those platters, you would have a head crash, and you'd basically lose all the information that's on that DASD. So we had all sorts of backup and restore procedures and things like that. Well, this has been replaced with what we call these DS8Ks, and the DS8K is kind of a generic term. There have been many different models that have come out over the years, but I'm showing on the left what it looks like, and if you open it up, you see on the right, you have solid state drives, or you have SCSI drives, and there's this special emulation that converts it over to the PyCon way of talking things is through these CCWs, channel command words. But at the end of the day, it's just good old fashioned disk that's all pooled together, and we're able to turn this kind of configuration into something that the mainframe has always had as part of its architecture. Okay, it's time to start switching gears and talking about AI in the mainframe. The terms that I want you to lock in on are Telum, which is really a code name for a model of the hardware, but it has an AI coprocessor on it, and that was the first one that was introduced a couple of years back on our Z16s. The Z17 is the most recent box, and it is really good at doing inferencing. Spire is brand new, and I
Sorry,
haven't
Dave.
gotten my hand on an Aspire yet.
Just real quick, Yatende, can you please go on mute? Let's see. I don't know if I can mute her or not. Just keep going, Dave. Yeah.
All right. Yeah, I'll just fight through it. All right. So Spire is the new card that IBM has introduced. I think they are available now that we're past the fourth quarter of 2025. And I did not get my hands on one yet, but it's got the promise of doing large language models, all the kind of stuff that Kyle was showing us. So the way IBM likes to couch it is the Telum, which is using is good for inferencing, and the Spire, which is good for large language models, is what IBM is dubbing as hybrid AI. So let's dig in some. So this is a picture of a Z16, the last model. The latest one is the Z17, and it hasn't changed all that much. You have 8 cores on a chip, and then they're organized into books, and then they're put into CPC drawers that we showed you in the picture a while back to get your 208 different cores of different core types. And again, we're not getting into the different core types today. Just think of them as being engines that you can run work on. They each have some level 1 cache, but these level 2 cache that's the interesting piece. And they have a notion of a level 3 cache, which is really the aggregate of all the L2s. And in green at the bottom is the Telum AIU, the coprocessor that's good for inferencing. And so that means that the AIU can access up to 256 megabytes of level 2 cache. The big change with the Z17 is that you're able to actually reach across from one AIU on one of these chips across to the other books of the mainframe and use its level 2 cache. So you have a much larger amount of memory that these models are able to use. And also, because the AIU has to be shared amongst these cores, you don't have any one core monopolizing it, because the AIUs from different chips can be utilized by the different cores. So that's kind of cool. What is that Telum chip and that AIU doing? Well, it uses an instruction, an assembler instruction. I think it's Becker 938 in the upper left. If you're an assembler guy, you would be interested in this. Now, we don't necessarily want to get down to this level of detail, but know that there is an instruction, the NNPA, which is Neural Network Perform Assist, and it's basically doing vector math. All those functions on the right-hand side are all the kinds of manipulations of vectors that you would expect to see in a AI environment. So you've got add, subtract, multiply, divide, min, max, all of those different types of things. And IBM has been adding more and more. So I would expect that the Telum 2 chip on the Z17 has more of these types of functions. But that is at the lowest level how you get the inferencing done. Now let's bring it up. We got down there in the weeds talking about assembler and all that, but you don't need to be using that kind of low-level interface. IBM has been building in the ecosystem and contributing to these open sources. The TensorFlows, the PyTorches have all had contributions from IBM. And the big thing to understand is that in order to do the inferencing and then also to do the Spire interactions for the large language models, you train it anywhere you want. You can train it on the ZBox if you choose, or you can train it in the cloud, but you just need to export the models in ONNX format. ONNX stands for Open Neural Network Exchange. And the file that it creates when you export your model is a protobuf file, which is basically JSON inside of a file, a binary file. And then you take it and you put it through IBM's deep learning compiler. And again, if you guys are interested in this, I've got videos that I've recorded to show how this gets done. But it ends up turning the ONNX file into an object file, which then you link together to create a load module, which is executable. So you're able to take your models that you've trained in your favorite place and you turn them into executable code. And then on the Z environment, we still have all these different types of softwares that you might know. You might be familiar with Java, you might have Python experience. It ultimately goes down in the Java through a JNI, the Java native interface, to execute that C code that calls that assembler instruction, the NNPA, at the end of the day. And then we have all these different platforms. The CICS is a transactional system that on ZOS is a flagship piece of the operating system, as is DB2. And IBM has published their Watson machine learning for ZOS to allow you to use the insights of fraud detection and healthcare and government and all those different applications that were written years and years ago. They can now, with the Watson machine learning, tap into the machine learning, and in particular, the inferencing engine of Telum. Now we're going to see what we're going to be able to do with Spire. So here is the Spire. It is a PCI card. And remember, we had up to 192 slots for things like the network cards, the coprocessors, the crypto coprocessors, the FICON, which is your I/O talking to those DS8Ks. Now you can use some of those slots for Spire cards. And the minimum number is 8. And you can bring them together as a logical cluster. And you can have, a terabyte of memory. So your large language models are able to execute. Now, an interesting fact here is that they consume less power than an NVIDIA card. The NVIDIA card is somewhere around 170, watts of power consumption. These consume around 70 each. So that's a good thing and a bad thing. It's a good thing in that it's green and it uses less power. It's not as good as the NVIDIA because it doesn't have as much speed, as much capacity as the NVIDIA. But we have ways to, cluster so many of these together that our new, AI environment, our large language models on the mainframe are very attractive. And then you don't have to take the data off the platform. You can stay on-prem, don't have to worry about cloud if that's a concern of yours. And we have these aggregations and these clusterings that just gives us incredible power. I think we're at the end here. So, the use cases of the IBM Telum is the fraud detection, claim processing, and all those types of things you see running down the left in blue. On the right-hand side is where we see the Spire card really help out. And again, this is new technology. I have not yet had my hands on it. I can't wait till I do. But it has the promises to loop in that stuff that Kyle was showing us, the code assistant, to be able to tell you what those COBOL programs written 30 years ago, what they're doing. And you've got all types of, online document processing We're going to be able to hook up RAG servers and MCPs servers to be able to do all sorts of great things with the Spire cards and the LLM. So put the two together, and you've got IBM's vision of hybrid AI. So I hope you found this interesting. If you have any questions, please come off mute, and Kyle and I would be happy to weigh in on any questions you might have.
Thank you so much, Dave, and thank you, Kyle. Any questions from the audience? You can go ahead and come off mute if you have any questions.
Hey, Phil, hey, Dave, by the way, that was a great presentation. Interesting stuff. Learned a lot. Thank you. I wanted to just add in real quick, Phil, if we run workshops, free workshops, if you'd like to sign up for one of those, please just reach out to me, find me on LinkedIn, or maybe I'll drop my email in the chat. But yeah, if you want to explore how to identify use cases, implement guardrails, write, help out with a new operating model for an AI augmented workforce. We have like a plethora of great interactive virtual workshops that we would be happy to take you through. So if anybody's interested in that, please reach out to me.
Yeah, thank you. And also, as everyone thinks about their questions, this is just an introduction. We want this conversation to continue because there's a lot that can be learned and shared here. There's a lot more to be understood because we know that AI is such a very vast and powerful tool that we're starting to adopt. I feel like this is just barely scratching the surface of what could really be discussed here. And I thank both Kyle and Dave for being able to condense what could probably be a 3-hour session from each one of them. And so I thank them for condensing that because I wanted to show that contrast of, where is AI being plugged in and how is it being plugged in just at a high level. So thank you both so much for breaking that down. I'll open it back up for anyone who might have any additional questions.
So does Copilot integrate into this mainframe hybrid AI stuff?
Copilot on mainframe, I do not know.
Just why the question is, so we work in hybrid environment, right? Mainframe plus distributed. So if a developer so we all talk about modernization. So everybody would be working on a PC or a Mac. So how do they leverage this mainframe capabilities, AI capabilities from distributed platform?
Well, from the distributed platform, you would be able to, the way that the mainframe applications are generally written these days is all around the onlines. Forget the batch for now. And there's all sorts of REST APIs that you can create to be able to communicate with the mainframe. And MQ, message queuing, is a very popular tool as well. So a lot of times the front ends are using, think about when you're accessing your balance of your bank account on your phone. It's hitting a couple of servers along the way through distributed, probably coming through cloud. And then it gets up to the mainframe, either going through MQ or going through APIs, REST APIs. Back to your question, if you're developing models, you can use all the tools that you're familiar with, the PyTorches, the TensorFlows, and stuff like that, and create your model and export it. Then you take that ONNX file, you compile it, and then it's up to the applications on the mainframe side of the house, the CICSs and the DB2 stored procedures and stuff like that, to invoke these models through Watson machine learning and be able to do the inferencing or the large language model manipulation. Don't have as much material on the Spire card and the large language models to date, but we'll definitely be researching more of that for you. So that's kind of the flow of how the mainframe would interact. Another thing is you can directly call from the distributed side of the house a REST API on the mainframe that talks directly to those models for inferencing and large language model interaction.
All right,
I hope
thank you.
that helps, Sanjay.
All right, yeah. So that kind of is one use case, right? So the other use case is somebody wants to do some programming. So would it be the right choice to use the mainframe, or is it good to have everything local, right? So
I mean,
it comes to the cost, right? So I know we can
yeah,
interface with mainframe to do everything, but is
yep.
it, if we compare costs of distributed versus mainframe, because that becomes the one of the key things, right, these days, that it's going to cost a lot to run any LLM. So is it cheaper to run an LLM on mainframe versus distributed?
I would think that you'd want to do your training and creating of your models in the distributed cloud environment. But when you're running them, you're integrating with your production workloads that have been running your business for the past 50 years. And you probably want to do that inferencing or interaction with the staying on-prem on the mainframe.
Okay, makes sense. Okay, got it.
Yeah, I wonder, based on Sanjay's question, can we, when other opportunities allow, expand the use cases on distributed and mainframe to help us further understand or get a better or clearer understanding what type of use cases would be best fit for which platform. But this is really interesting. Thank you.
Yeah, I think that's a great idea for future conversations about this. So yeah, thank you for that. Well, we are 2 minutes over time. Do we have any last questions here before we wrap things up?
Shiva has one, right? Shiva, do you want to just ask to Dave?
Oh, it's in the chat.
It's in the chat. So Shiva said, Dave spoke about speed and the performance of AI chip and processors. To what extent is it valuable to understand the underlying hardware characteristics, for example, the architecture, memory, accelerators, and how much can those knowledge actually help?
Well, I did talk a bit about the AI coprocessor, the Telum, and it's sitting right there next to the core. It couldn't get any closer unless IBM were to take that AI coprocessor and put it on the core itself. And they've done that for other technologies. Compression is one. But so that inferencing is got incredible amounts of capacity, and because it is so closely coupled with the cores, it's incredible. It's fast. You're going to be able to get your transactions, your CICS transactions that you need to be sub-second. You're not going to cause them to become seconds or it's going to stay sub-second response time. We don't know yet about the use cases so much for the Spire card. And as Phil was saying, and Nancy, we're going to want to dig into that and get back to you with more details on the performance of the Spire. The Spire is a PCI card, but it's still inside of the mainframe enclosure. So it's going to be incredibly fast. You don't have to have network latency as you do if you're trying to go from the mainframe to a cloud for inferencing. That I think has been tried. It's not as fast. That's why IBM has put together these two offerings. That together, the Telum and the Spire equals hybrid AI. Hope that helps.
Excellent. All right. Well, I think that about does it. Last chance for questions. Other than that, I think we'll go ahead and wrap up. Thank you everyone for attending. We will be releasing the recording here in either later today or sometime this week, and so everyone can look back and rewatch or watch the recording now and enjoy. So thank you, everyone. Thanks again to Kyle and Dave. Have a wonderful
Thanks,
day.
Phil. Thanks, everybody.
Thanks.
Thank you.
Thank you.
Bye.
Thank you.